Maximize cloud efficiency with Do It, the trusted partner in multi-cloud management for thousands of companies worldwide. Visit doit.com. That's DOIT.com. Do It, your cloud simplified.
Packet pushers.
Welcome to Day 2 Cloud, you amazing human you. I'm Ned Bellavance. With me is Kyler Middleton, and today we are talking about Kubernetes clusters on the public internet. And it sounds scary, and it kind of is, isn't it, Kyler?
Absolutely. Kubernetes has access to a lot of secrets on the control plane, but also a lot of access on the data plane to pivot into your network. And if someone compromises it, they can delete your Kubernetes cluster and potentially other resources too. So it's important to secure it.
Yeah, just a little bit. And this was brought up by our good friend, Lee Briggs. He's a friend of the show. He's been on before. He's back, and this is something he's feeling passionate about. So let's hear what he has to say about securing your Kubernetes clusters.
Welcome, Lee Briggs. Thank you so much for coming on the show. We usually start off with, who are you? What the heck do you do? What brought you here?
Thank you so much, Kyler. Yeah, this is my second time on the podcast, I think, and I've recently transitioned into a role at Tailscale, which, I know lots of people use in their home environments, but I'm on the solutions engineering side, so in the kind of enterprise setting. So lots of networking and a lot of classic old school system administration coming back. So understanding route tables on operating systems and all that great fun stuff. So it's been really great. I think I'm in my 6th week now, but yeah, I'm really enjoying it. I think Tailscale is a great product, obviously. Otherwise I wouldn't work here. And I think it's kind of adjacent to what we're going to talk about today as well. So
Yeah, I'm very familiar with the free product, and I've used it in the past. We'll have a wrap session after this about all the things that I found wrong with it and that you immediately need to fix. No, I'm kidding.
I'm right on it.
Also, genuinely like Tailscale in general. And God, you said route tables and dealing with all that. That brings back networking nightmares. But fortunately, we have smart networking people on the show like Kyler, who has a whole bunch of background in that. So I think she's going to be carrying the weight for that. Our topic today is around public access to Kubernetes clusters. So, Lee, you wrote a whole blog post, or you're in the process of writing one. Can you give us a little background in what you're talking about and your concerns with public access to Kubernetes?
Yeah, so I think the best place to start is kind of how I ended up where I am today. And prior to being a solutions engineer, I was a DevOps engineer, cloud engineer, platform engineer. The name changes every week. And part of that role was kind of managing large scale Kubernetes clusters. And before a lot of the cloud providers had easy one-click access to, EKS in Amazon or Azure Kubernetes Service or GKE, you had to build your own clusters. And because it was an API, even though it had authentication, the mindset was, okay, we're going to put this in a private network. The cloud providers seem to have gone in a different path. And the default setting for almost every cloud provider is ask them for a Kubernetes cluster and they will put the control plane or the API server. I'll use those terms interchangeably on the public internet. And I kind of understand why they've done that, but I think we've all come to accept it in a way that I just don't think we should. In the same kind of way as if this was a database, you might need access to it, but I think everybody would kind of shudder if we were talking about putting our databases on the public internet. But for some reason, with the Kubernetes control plane, we're just totally okay with that.
It's interesting, Lee, that you brought up databases because, at least on the Azure side of things, the original setup for Azure SQL as a service would give you a public endpoint for the database, and it was not firewalled in any way. They've changed that since that initial rollout, but that was the default setting and the default setting for like S3 buckets going way back in S3. So there seems to be a trend here.
Yeah, and I think the trend really is understandable from the sense of the cloud provider is incentivized to make you provision more stuff because then they get money. And they don't want to allow you to provision stuff that seems broken. An example of it being broken is you can't access it or you can't interact with it. And putting a Kubernetes control plane behind a private network or an unroutable network would leave most people that haven't done this kind of thing before thinking, well, this is broken. It doesn't work because I can't access it. I can't interact with it. So it's kind of understandable why. The real surprise is that, I can kind of understand it from the getting started perspective of like, I just want to be able to understand how this Kubernetes managed service works. But then the fact that it is the default and there is no warning box or alert mechanism or like, hey, this is probably not a bad idea. Or in the case of the Azure database solution that you mentioned, I believe they've deprecated that now and you actually can't create new databases with that service anymore. And you have to use flexible Postgres servers or something along those lines. I can't remember what they're called. So For the databases, we seem to have kind of transitioned into this path where, okay, we're accepting this is not a good idea. But for Kubernetes servers, we're just like, cool, this is fine. And, I think we could talk in depth about that. But that's kind of what led me to write the blog post. I like to stir up some sort of controversy because I think it helps people ask questions. I don't necessarily have to be right, but at least we're asking questions about it.
And that is Ned and I's whole job is we don't know the answers, but we're trying to ask all the questions to like smart folks like you that come on and can tell us about this stuff. And for instance, when you say databases, I think of Kubernetes because it is basically a database that's driven by an API, and it includes a lot of secret stuff, including literal secrets to probably a lot of your applications. It freaks me out that that would be on the internet.
It's very privileged as well, right? Like you have the full access to kind of manipulate multiple different nodes and multiple different workloads. And the argument, I think most people who are listening to this would think, well, yeah, but you need to authenticate, right? Like you have to use the cloud provider API to authenticate. So the fact that it's on the public internet is okay. But again, if we kind of use that parallel of a database, you wouldn't put an unpassworded database on the internet. For sure. Well, at least I hope you wouldn't. Or you wouldn't put an SSH port on the public internet with no authentication. We also wouldn't do that with authentication at this point, I don't think, right? Like we generally, the kind of security by obscurity mechanism with SSH is, oh, I'll put it on a different port and then nobody will be able to know where it is, right? The thing that kind of prompted me to go down this path was I did a Showdown search. If you're not familiar with Showdown, I'm sure lots of people are, but in the interest of making sure that everybody understands what it is, I did a Showdown search, and Showdown basically port scans the entire internet on a regular basis to see what things are out there, whether it's your home camera or a MySQL database or whatever. And there's nearly 1.4 million Kubernetes clusters on the internet right now across a wide variety of cloud providers. To put that into perspective, there was 800,000 Postgres servers that I found. So like, it's a big problem. I certainly think it's a growing problem. And I think that we should at least be asking why the current state is what it is.
Okay, this is my own personal perspective. I think that Kubernetes is so advanced and cool that it can't possibly have any flaws that would lead to compromise. And I realize it's kind of the opposite, right? The new stuff, the new hotness is where we find those big vulnerabilities that lead to like total RCE and compromise. And if we discover something like that, well, now you have 1.4 million nodes in your bot cluster. And that, oh my goodness, I'm just freaked out this whole talk so far.
It's a huge attack vector. Like, again, to play the devil's advocate of my own opinion here, the argument that I think a lot of people would have is, well, Kubernetes releases every 6 months and they're very good at cutting patches for security vulnerabilities. And, one of the problems for maintaining Kubernetes is how fast the ecosystem moves. And you have to do an upgrade every 6 months because that's the current release cadence. So, yeah, I mean, they find a vulnerability, they patch it. That's how open source works. This is great. But then to put that into perspective, there is such a huge problem with old Kubernetes clusters just hanging around. It's certainly in Amazon Web Services. The Amazon Web Services just announced a new, very, very expensive billing cycle in which if you use an out-of-date Kubernetes cluster, they're going to charge you through the nose in order to continue running that. I mean, it's because people just don't upgrade these things. It's really hard to do it. And lots of people are still on 1.21 while we're on 1.29. Like these vulnerabilities are out there, right? We just haven't found them yet. And I think what we've seen in the last couple of weeks with the vulnerability around the XC tar compression stuff, like it's interesting we're doing this podcast this week because I think a lot of people will be in a heightened sense of awareness here.
Right. And I think it's not just the vulnerability and being able to compromise that Kubernetes environment, but it's also the fact that from that Kubernetes environment, that could provide a way to access the rest of what should be a protected network. Because if I think most Kubernetes applications don't live completely inside of Kubernetes, they reach out to other things. Most enterprises are going to have a VPN or some sort of tunnel back to their data center that's connected into these VPCs and VNets. So if you get that toehold, whether it's a Windows box someone left RDP on or a Kubernetes cluster with a public endpoint, you're really just providing a beachhead for the attacker to go in and expand out from there.
And in my experience, those EKS runner nodes have, at least this is the AWS side, an IAM role that lets them do a lot of stuff, read a lot of secrets, access a lot of other resources, potentially create and delete if you're using Terraform for CRUD type operations on EKS. That's a lot of access that you might be granting to a stranger on the internet.
Yeah, the lateral movement problem, I think, is, I will preface this by saying I'm an amateur security enthusiast, right? Like my job title doesn't include any sort of security title, but I've worked with a lot of information security teams or infosec teams at previous roles or like during my day to day. And one of the great things about being a solutions engineer is you work with infosec teams from a wide variety of different companies, and they always say the same thing. Like, we recognize we cannot create the perfect utopia of security, right? Like, there's going to be vulnerabilities in our ecosystem, and we're aware of that. What we're trying to do is prevent lateral movement and create defense in depth, right? And you just mentioned that, Kyla, the lateral movement. Like, you get into a Kubernetes cluster, you likely have access to IAM roles, at least from application IAM roles and IAM roles for service accounts in AWS or whatever. You're almost certainly going to have access to nodes to be able to pull. And like, I thinking like an attacker, if I get access to a Kubernetes node, I'm at least going to be able to steal your intellectual property, right? Like, I can pull the Docker images, I can extract those super easily, and I'm off and out the door, right? So creating that defense in depth is really, really important. And step one of defense in depth seems to be, let's not put this thing on the internet, right? Like, at least make you do the hard work of getting inside the network perimeter and then go from there.
As a counter argument to that, thing that I've heard a lot is that defense in depth is unnecessary. If you are putting the proper security controls in place, then you shouldn't need this like 16 shell approach, because each additional layer of security you add also introduces its own vulnerabilities, right? If I add a bastion host, let's say, well, now I have to worry about the security of that bastion host. And if I add specialized IAM roles, well, now I have to make sure that I wrote the policies for those IAM roles properly. So each additional layer of security could add its own insecurity. So what is the counter argument to that when it comes to Kubernetes and these endpoints?
I'm actually going to add on to your potential counter argument as well, in this interest of being, the eternal devil's advocate. Adding defense in depth also makes users immediately want to just go around the controls, right? Like, I think we've all worked I'm sure we've worked in environments where there's shadow IT because they don't want to have to jump through the hoops of security that, the defense in depth that they put in place. And I've personally been frustrated by this, right? Like, hey, why am I having to open a Jira ticket to open a firewall port so I can do my job? Like, that's just really frustrating. It slows the business down. It gets in the way of everybody. So yeah, I definitely understand that. I do think that network perimeter is the castle and moat kind of part of the problem, right? Like, being able to have a secure network boundary at least makes an attacker have to think about how they're going to get over that particular quote unquote proverbial moat before they can even get started with the defense in depth stuff. I definitely agree that layering on lots and lots of defense in depth, it can be really painful, but I think maybe this is just a philosophical thing on my side. Network perimeter just seems like basics, right? Like, if you think something's relatively important, put it behind a network boundary to start with. And I'm sure there'll be people who listen to this who are nod their head, and I'm sure there'll be people who listen to this who are like, oh, that's so silly. I guess that's my perspective at this point.
There's this idea of the future of this VPN-less everything exposed on the internet. Everything gets an IPv6 address on the internet that's routable future. But I agree. I think obfuscation is still incredibly useful because firewalls and complexity protect you. Your devil's advocate argument is totally valid. If you create friction, your developers will go around you. They will put an EC2 node on the internet and they will pivot through it and do all of their job. But I think that obfuscation tends to work, not just changing the port. That's a bad example. But, layering and firewalls and putting it internal, I totally agree that helps.
I do just want to come back. I hope we don't end up in a VPN-less world with everything in IPv6, because then that means I don't have a job anymore. But yes. And I also think that these network boundaries create problems, which is what the cloud providers were trying to solve when they just like, we'll just put it on the public internet and like, let's make it easy, right? When I'm talking to customers at Tailscale, they will like, the default setting in Tailscale is an ACL that is allow access from anything to anything. And the reason for that is because we don't want you to install and Tailscale and get started and like lose all connectivity to everything and think, well, this is broken, right? You have to make a conscious decision to implement these security rules or implement this kind of network perimeter, because it's not the easy path. I think you'd be pretty smug if there was an RCE in the Kubernetes control plane and you had a private cluster, right? Like, you wouldn't be fighting off Bitcoin miners or, somebody with a vulnerability that they can just, again, spread into the 1.4 million clusters on the internet. I think you'd feel pretty good about yourself, right? We had this stuff with Heartbleed and God, it must be 10 years ago now, I guess, Heartbleed, where all those people who were using non-standard SSL libraries were like, sucks for all you folks, but it doesn't bother me, right? Like I could just get on with innovating in my business. So I think there's a lot of arguments against doing something like this, but it seems like low-hanging fruit to me.
So, assuming that we accept the premise that having a public addressable API endpoint for your Kubernetes cluster is probably bad,
Yes.
it seems like a simple solution would be I'm just going to add some firewall rules to whatever the cloud service is to only allow access to this API from these public IP addresses. Do you think that's good enough, or do I have to do something more drastic?
If you have an office, I imagine that you could just add a security group to the control plane or a network security group, depending on the cloud provider, that allows access from your office. And excellent, great, this is all good, right? I think we live in a pretty remote friendly environment now. And I don't think it would necessarily be the case that you would want to add the egress IP of every single user. That'd be a pretty long security group list of everybody's public IP. And every time it changes or every time you reset your router, you get a new IP address. I don't think that'd be very fun at all. The other approach that I think really is possible here is the approach that I kind of advocate for in the blog post is you put it inside a private VPC or a private network, and then you have to solve the problem how you route to that network, right? And
Mhm.
you even mentioned earlier, like lots of organizations have direct connect back to their data centers or they have direct connect back to their office. And like most organizations can route into a private network somehow. You just have to work with your network team to get that set up. I personally advocated for, and I wouldn't be doing my jobs as a sales engineer if I wasn't talking about this, but I advocate for using something like Tailscale in order to be able to route into that private network, right? And there's multiple different ways that you can solve that. If Tailscale is not your VPN of choice, there's almost certainly a solution there. But having that be on the front of your mind, if you're listening to this and you know that your Kubernetes control plane is on the public internet, I think the next question you should be asking is, how do I get this in behind a private network? It's more than likely going to involve VPN, I think, not kind of security groups from a public internet address.
Totally agree. Yeah, internal routing is just gonna be the solution because those public IPs change, and I'm not going to give AT&T $5 a month for a static IP on the internet. I refuse.
I mean, I'm surprised that it's only $5 a month, quite frankly. The other thing with managing security groups is that, back to your point you made earlier, Ned, security groups generally tend to get stale. If you're constantly updating a list of whitelisted IP addresses, it can get stale pretty quickly. People lose access because their IP address changes, or, you spend more time updating that whitelist than you do actually doing your job. I've been unlucky enough to, in previous roles, have to update a list of IP whitelists for enterprise customers who wanted to have that as a solution. It's a full-time job in some situations.
If I'm an administrator for a Kubernetes cluster and it's an old version where, yeah, the 1.21 that you mentioned, and it's on the internet and we move it internal, is that good enough? What should we do next? Like, I know that's sort of beyond the scope of the network discussion, but what do I do?
Kubernetes is pretty good at backporting fixes, but once the actual end of life happens for a version, those fixes don't get backported. And I haven't looked it up, but I think they backport fixes for 2 years or maybe 3 years. If you're on a version of Kubernetes that's older than 3 years, step one should be upgrading. There's strategies out there for being able to do this, and it's hard and it's not fun. And I think it is one of the overarching problems that comes with Kubernetes that is less often talked about, right? Like, cluster upgrades, node upgrades. In most situations, you have to build a whole new cluster with the new version, then migrate all your workloads across. Like I personally, when I was managing large-scale Kubernetes platforms, that's the way we did it. We never upgraded the cluster in place because there's just too many things that can go wrong. It's a high burden to bear. I'm sure you've had people on the show before that talk about the Kubernetes overhead and the operational costs. But to answer your question, the first thing should be getting onto a modern version of Kubernetes should be step one. Ensure that you have those backported security fixes. And then really the defense in depth argument will come from the actual ability to be able to auth Z into the cluster itself. So like lots of people just hand out cluster admin, right? Like they just say, cool, go nuts, have access to all namespaces, you have access to all the workloads, you have access to do anything you like. Again, it's an attacker's dream, right? They love this, the fact that you are very liberal with your kind of permissions. Again, the default setting for EKS in this particular case, which is what I'm most familiar with, is actually pretty good because they only give cluster admin to the person who creates the cluster. And then you have to do a whole bunch of authentication mechanisms, and it's changed over the years. But then you have to add groups and roles to be able to do that. So that's actually pretty good there. But those three things will generally put you in a pretty good place, I think. Modern version of Kubernetes in a private network, network, thoughtful consideration about who has permission to do things, I think that'll make most information security teams happy. And I think you'll pass most audits that you really want to pass.
To go back to the original reasoning behind why the cloud providers do provide that public endpoint, it was because they want it to not appear broken. They want it to be easy for people who are just trying it out. And so, how do we maintain that ease of use or that simple setup or low friction experience while still adding this additional layer of security? Is it two different deployments? Like, what are your thoughts on that?
I really think that we are due an innovation in the networking space on the cloud provider side. I suspect that the advent of things like WireGuard, which Tailscale is built on, will likely mean that we'll get tighter integration into much easier networking. Like I think the AWS default VPN right now is OpenVPN. I'm not going to badmouth a competitor in this conversation, but like things have innovated since then. I personally, the way that I advocate to customers is that you create a VPC, and then step one is you create what we call a Tailscale subnet router, which allows you to advertise the entire address space for that particular VPC. It removes all of these issues from the equation. You immediately have access to that private network. And what I suspect we'll see over time is the cloud providers do this, right? They follow in the footsteps of other innovative organizations. They will likely make it a lot easier, I think, in the future to give you private access to that network. I think today Amazon announced that after I think Amazon was launched in 2013 or 2014, you can now finally restrict access to the AWS console to a private network as of today, which I think is their most enterprise requested feature for the lifetime of Amazon, and they finally got around to doing it. So like they are aware of these problems, I think. It's just a hard problem to solve in a large scale. And what I think we'll see is they'll make it easier to access these private networks, and you'll be able to add a VPC endpoint that is basically a VPN at some point in the future, I suspect. My recommended solution, of course, is to use Tailscale and to use a subnet router. And then if you look at the blog post, which I'm sure will be in the show notes, there's other solutions that you can use to talk directly to the cluster control plane with Tailscale. But I think that will be the innovation that we will see in this space. And my prediction or suspicion is that we'll need an XZ vulnerability-like thing in Kubernetes that is widespread before they move in this direction. And Kubernetes is a fantastically written piece of software with wonderful governance and great code reviews. It may be a long time before we see an RCE or a vulnerability that is this widespread. It could be a long while, but I have no doubt that it will happen because that's just the nature of open source software, right? People make mistakes. We're all human. And, I think ultimately we'll end up in a situation where there will be a vulnerability that will cause people to act, which is the security thing, isn't it, right? We're all very reactive when it comes to security. We all do things after the fact. Ransomware has been around for a long, long time now, and people are still being hit by it. So, it is just the nature of the thing.
Maximize cloud efficiency with Do It, the trusted partner in multi-cloud management for thousands of companies worldwide. Do It's innovative tools, expert insights, and smart technology make optimization simple. Elevate your cloud strategy and simplify your cloud spend. Visit doit.com. That's DOIT.com. Do it. Your cloud simplified.
Yeah, there's no security engineer that's out there saying, I just don't have anything to do. This stuff is so easy.
Yeah, it would be great if they could just snooze at their desk or something like that, right? It's just not the way we do things. I never really envy the security engineers or the InfoSec people because it's a very reactive job, right? And you're always thinking of things in the worst case scenario, and you're always thinking about things in high levels of scary probability. And part of the reason why I never moved into security, and I call myself an amateur enthusiast, is because I like to think about these things from a security perspective, but I don't want to be the one responsible for watching people do things that are going to go around security controls. I don't envy those people at all.
Paranoia as a job skill is how I think about it.
Yeah, I'm anxious enough as it is, Kyler. I don't need to be anxious at work too,
Absolutely. The hackers that I know, it sort of consumes your whole worldview when you're in the security space. That what goes wrong if someone hacks my car? What if someone hacks my door? What if someone hacks my, home camera? And it kind of eats your sense of security.
I have a very good friend who takes the Wi-Fi card out of their television. And I just when we go to coffee, he sits with his back to the wall. And I'm like, I get it. Like, I understand where you're coming from, but, it just seems tiring, I think, from a security perspective. That's just me. He's a wonderful friend. And I always rib him a little bit for the Wi-Fi thing in the TV. But some people have different levels of threshold, I think.
Right. And I think that's important to bear in mind when it comes to doing this equation from a business perspective is you have to balance the level of security you implement with how much benefit you're getting in that and how much that might get in the way of the business accomplishing their goals. So it's like that security seesaw.
Yeah, I've actually learned a lot in this particular space. I remember being, system administrator slash cloud engineer. I didn't really have a full understanding of the importance of my role with regards to business objectives, right? Like, there was very much a sense as a personal individual, a sense of like, this is the quote unquote right way to do things, and it's going to take a little bit longer, but like, it's important and like the business objective don't really matter. And as I've moved into a more sales focused role and been more aware of like how businesses succeed and fail, my attitude here has changed fairly significantly, right? As system administrators or cloud engineers or platform engineers or on the operations side, our job is to support the business being successful, right? And in order for the business to be successful, you have to move quickly and innovate and you have to be, on top of things and all that kind of stuff. The reason why security is often left behind is because it doesn't actually provide a whole bunch of value until it provides value in the sense of like, we've been attacked and now the chickens have come home to roost type thing. It's been a long time since the book was published, but I always think anybody who has this mindset should read The Phoenix Project by Gene Kim and other authors, but I think Gene Kim was the first author
Mhm.
because they have a character there in John, the security person, who has this kind of epiphany during the book where he realizes I am just creating problems instead of solving them. And he kind of goes through this very stereotypical monk-like transformation where he becomes this Zen sort of Buddhist type. It's obviously exaggerated for the book, but I think it's an important lesson for those kind of operations folks and those system administrative folks and those information security folks to learn that the business is important. And part of the reason why, and to bring it back all the way around, part of the reason why Amazon puts these things on the public internet or Azure puts these things on the public internet is because it has direct impacts on the business success for using that product, right? I think EKS is the fastest growing Amazon product for the third year in a row. There's a reason for that. It's easy to use.
I think Azure AI may have taken the cup last year, but AKS was also one of the fastest growing services on Azure for a long time. And for obvious reasons, and they went the public endpoint route. Now, if you actually read through their best practices and hardening guide, one of the first things they tell you is to put it on a private network.
Yeah.
But of course, if you click next or next finish through the wizard in the portal, it puts it on the public internet.
Yeah, or you use Terraform and you look at the settings, the default is public true or whatever. I bashed the cloud providers a lot during this conversation, I think, because they're big conglomerates and they could take it. But I do think to complement them, both the cloud providers that I use heavily, Azure and Amazon Web Services, allow you to modify the cluster to put it in a private network without destroying it. There's
Right.
lots of those cloud provider APIs that are immutable in the sense that once you create the cluster, it's stuck like that, right? Like you want to change that property, tough, you're gonna have to destroy the cluster and start again, which I think would mean most people would never do this job of like moving it into a private network. Both AKS and EKS allow you to modify the network settings to put it behind a private network with no downtime and no impact to the cluster itself,
Right.
which great, because I'm sure that took a lot of engineering and it also incentivizes, if you're listening to this, it incentivizes you to think about how you're going to do that because it means it's not a destructive operation.
Right. I can give you a little background from the Microsoft side because I happen to know some people who helped build the AKS portion of it. And initially, the public API endpoint was the only option because they hadn't widely rolled out what's called private link today.
Mhm.
And so the control plane ran in sort of a subscription that Microsoft manages. And to present that endpoint into your subscription and your virtual network, they needed that private link service to be available and running and out of preview. I think it was in preview when they first did AKS. So it took them a few iterations before that service came online and they could go, okay, now we can do the private endpoint because we can put that private link in your network and you can refer to that instead.
There should be kudos passed to Microsoft for that because again, the engineering work for that is non-trivial and probably doesn't have a whole bunch of impact on their bottom line, right? And like if they charge more for private clusters, you could kind of understand them doing it, but they did it because they knew it was the right thing to do. Now we all as users have to go and do what we know is the right thing to do and move all of our public clusters into the private network.
I love seeing this seesaw of put everything on the public internet, which we saw from both Azure and AWS. And now we're sort of swinging back around to like, let's put it inside, which I feel is a very common sense solution, like we've discussed. But I love seeing the Azure like just in time bastion access and solutions from Aviatrix and Tailscale that sort of have this sort of virtualized just in time VPN. I love seeing this stuff because I think it definitely protects you no matter what software you're running. If you just lower the attack surface, you're improving your security posture. And that's very important.
So I think 15 years ago when I got into this industry, the idea of having a zero trust network was just completely beyond the scope of reason, right? Like you had DMZs intentionally where like this was the scary zone. And now we're in a place where with a variety of products of which Tailscale is one, implementing a zero trust network is a few clicks of a button or a few API calls, right? And we've innovated so much in this space. It's really powerful knowing that we can have this kind of zero trust consideration for a lot of these things. We need to change the mindset when it comes to certain things, right? And I think databases and SSH ports are kind of like ingrained into a lot of those folks who have been in the system administration space for a long time. Kubernetes, I think we'll get there. I do think we'll get there eventually. And I hope that, in 10 years' time, when I do a showdown search, I'll be hopefully less than 1.4 million. I suspect that might not be the case, but hopefully I can look back and think that I had something to do with that, hopefully.
Usually when I see a bastion service or something along those lines being introduced or getting started, it's almost always providing SSH or database access. That's the example they go with 9 out of 10 times. I'm curious to see if that's going to shift a little bit and you'll see more and more examples out there where it's a Kubernetes cluster that you're trying to
Mhm.
access instead of just SSHing into, some box that you're managing.
I've actually talked to a customer who used SSH port forwarding to be able to access a private EKS control plane. And so they had built this wrapper script where they have a Bastion host and they have a wrapper script around the kubectl command, which basically would do an SSH minus L port forward for like port 8443 to port 443. And they were like, yeah, we kind of recognize this isn't great and we'd like a better solution. And which is why they kind of like reached out to us at Tailscale. But it's there. People are doing these things. There's lots of third-party tools now, and I'm not going to name any names, but there's lots of third-party tools now who allow you to build things like management control planes and things for your application, and they need database access. And the way that they recommend is to create an SSH bastion, right? So you're still exposing some part of your private infrastructure to the internet via the SSH bastion at the end of the day. What I am always kind of surprised with is there's not been a real push to integrate with third-party VPN providers or even cloud-based VPN providers, right? Like we have an established solution in the space. I think we all just kind of hate VPNs, right? I certainly remember, once we started remote working and you'd be on a Zoom call and you're on the corporate VPN and the VPN disconnected and everything just crashes. You have to restart your laptop because it just completely hijacks your network adapter.
Hmm.
Part of the reason why I joined Tailscale is it's really great being able to just disconnect from Tailscale in the middle of a Zoom call for a customer and it doesn't affect the network at all. And, WireGuard is a big proponent of this kind of like, we're not going to hijack the network stack. Things have changed in the VPN space pretty dramatically.
That's wonderful. I agree. Every engineer I've worked with hates VPNs. The reason we say it's the network, it's always the network, is because it's hard. It's obfuscated and it's complex and it's hidden. And like, I just don't care about it until it breaks. And then I'm mad. And that causes my client to break all the time.
I've never had a network engineer love the job because they only ever get contacted when things aren't working, right? Like nobody ever
Mhm.
calls a network engineer and says, hey, you're doing great. I had no problems today, which I think is really sad because it's a hard job and it's really, really necessary. But, it's a very thankless task, definitely.
Maybe we should put that on the national holiday calendar, like Network Admin Appreciation Day.
We have a system administration appreciation day, but we don't have a network administrator. Maybe we'll make it, what is it, April 3rd today. Let's dub this network administrator appreciation day.
I'm making a note. It can't be that hard to get a national holiday, right?
But there's all kinds of them now. Yeah.
Everything.
Yeah.
It sounds like basically what you're advocating for, if I can summarize and correct me where I'm wrong here, is if you have an existing Kubernetes cluster today with a public endpoint, move it to a private endpoint and put something that still allows people to easily access it who are authorized and should be accessing that cluster so it doesn't get in their way, but make sure that that service, whatever you choose to use, is really well secured through some sort of technology that's well known, has been hardened over a long period of time, and has a really good identity provider on the back end. Is that pretty accurate?
Pretty much it. The only thing I would add to that is that don't be intimidated by this because the cloud providers have made it way easier than you think it is, right? Like it's not a destructive and scary operation. It's a single API call in most situations. So it's easier to do than you think. So consider it, I think is probably what I would add to that.
There's always this deep-seated fear, and this has happened to me in networking land, is I make a change to the management plane or the control plane, and suddenly I can't get back in to undo the change.
That's such a scary feeling on your router when you type that command and hit enter and think, oh no.
Oh no, well, I gotta go drive 8 hours.
I've been in the industry long enough to know that, yeah, you have to get on a plane to go and fix it, or, you're plugging in crash carts into servers, and you can't really do that with Amazon, right? I don't think they'll let you in their data centers. So I get it. Like, I understand the kind of scariness factor of it. And the Kubernetes API is the gateway to the kingdom. And so you need access to it to be able to do things. But it is possible to architect this in a way where you have backup access and all these different things. And it's really actually not that hard. It is really, really possible.
You're changing the Kubernetes control plane, but you still have access to the AWS or the Azure control plane to undo that change if you had to.
Yeah, you could just go and change it back to public if you really need to. It's not super difficult to do.
Yeah. And you can always spin up a test cluster and do the migration there and see how it works out. It's like, okay, that's a great thing about the cloud is I can spin up a test version of whatever I'm trying to do in production and see whether I break anything.
Yeah, you usually have to go and make a cup of coffee because those clusters take at least 20 minutes.
A little bit of time.
Yeah.
Cool. Well, this has been a fascinating conversation. If there are a few key takeaways you wanted listeners to come away with, what would they be?
Making things private or putting things in a private network is not as hard as you think it is. Don't rest on your laurels when it comes to these kind of security considerations. And I think the final one is you have an implicit level of trust in the cloud provider, right? Like there is always going to be some level of trust that you have when you adopt cloud computing as your platform of choice. But that doesn't mean that you should just kind of be asleep at the wheel and make decisions that let the defaults be the defaults, right? We've seen this with S3 buckets, we've seen this with databases. Let's move on to higher level constructs like Kubernetes clusters now.
Perfect. And if the folks that are listening at home today want to hear more from you, which I absolutely do, where can they find you on the great big internet?
I have a social media account of whatever it's called this week, Twitter, X, or whatever its name is, and it's at Briggsell. I'm on LinkedIn at Briggsell. And for those times when a tweet thread just will not do the job, I also write on my public website, leebriggs.co.uk. Generally try to write once every month or once every 2 months about things that are just interesting to me. There's quite a few blog posts there on my previous role in infrastructure as code, and I'm starting to write more about kind of networking and the things that are adjacent to Tailscale. So I would love people's feedback on those posts as well.
Perfect. And links to all of that will be in the show notes, so you can click through and find those. Thank you so much to Lee for appearing on Day 2 Cloud today, and virtual high fives to you at home for tuning in. If you have suggestions for future shows, we would love to hear them. Fill out the request form on day2cloud.io. And if you like engineering-oriented shows like this one, visit packetpushers.net/subscribe. All of our podcasts, newsletters, and websites are there, and it's all nerdy content designed for your professional career development. Until then, just remember, cloud is what happens while IT is making other plans.